Okay, we're good.
Okay. All right. So for question 3, now what I'll do is I'll just say the answer, and if our answers aren't the same, then we will go through the question. Does that sound good?
Yep.
Okay. So question 3, I got 0.175.
Hold on. Question 3.
I didn't get that.
Okay. What did you guys get? Because it's very possible that I was way off.
Well, I was just struggling to see if I have a problem with this applet. I don't know why. I don't get it. I'm struggling.
I'm so glad you said that because I feel the same way. It's like I click on the greater than, and then you put in the z-score, and then it takes in the other half, and I'm like, is that right? Is that wrong? I don't.
Gotcha.
So this one, the z-score on the left is negative 1.35. On the right, the same. So I have that up.
Mm-hmm.
And it's asking on the two sides outside of that, what's the total, correct? Am I interpreting that right?
Let's see.
The normal curve.
So wait, you guys have to put it in the normal distribution? I mean, in the applet?
You put in the z-score, right?
Yeah.
Yeah.
Yeah, you put in the
Okay, maybe that's why I
z-score.
didn't get the answer.
Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358.
So
So what I did is I highlighted both of them. I highlighted to the right and to the left.
Right.
What did you
And
guys get?
I got, now that I did, I got a different answer. And I got 0.1745.
Yep.
Okay, before I got 0.0872. I must have just, sometimes you have to click it and then re-click it.
Yeah, so I actually took off one of my shaded areas and I got 0.0872. So if you click and you have the blue highlighted on both sides of the curve, then it comes out to 0.175.
Oh, I shaded the middle. I thought they wanted what the middle one was.
It says the curve that is to the right of the positive number and to the left of the negative number.
Okay, so it's 0.1745.
Yeah. Did you get that to come up, Carrie?
Yeah, I got it to come up.
Okay.
I just shaded it wrong.
And it says round to 3 decimal places, so it would be 0.175.
Oh, thank you. That's what got me in trouble on the last test.
Okay.
Yeah, rounding will get you for sure.
And just not percentages, decimal points. That's what I got me last time.
Okay, yeah. Okay, so moving on. Question 4. I put the distribution of the sample means. So,
I did too. I wasn't sure, but that sounded good.
I did as well.
Okay, well,
I didn't understand this question, so I put this cannot be determined from the information given.
well, let's see. It says, which of the following will have a smaller standard deviation? So in other words, if you're looking at a line that has a whole bunch of numbers on it or stuff on it, it says if there's 9 observations, 9 little dots on this line, and they're randomly drawn from a population, so which one will have a closer knit group of numbers? So it says the individual observations would be like, let's say you picked out one person from somewhere and then another person from another place, and then you just kept doing this, then you'd kind of have stuff all over that line. But if you get the distribution of the sample means, meaning you get the averages of these individual people, then what'll happen is those averages are going to come out to be closer together for each dot that is on the line. That's probably a weird way of describing it, but that's.
No, I actually get it now.
You get it now. Well,
yeah.
Okay, so
so
if you get the means would actually have a smaller standard deviation. They'd be a little closer together.
Okay. Yeah, that makes sense.
Yeah. So
Thanks.
I guess we'll roll with that and see what happens. Question 5. It says, well, I put down the law of large numbers.
I put down normal distribution, but I just totally didn't think this. I don't know. I kind of quickly thought through it.
Okay.
I first did the law of large numbers, but then I put it back to the central limit theorem.
Okay.
I wasn't sure. And I know I talked to Brother Richmond yesterday, and he said that is going to be put on different quizzes in different ways. So,
So the sample size increases. So let me read the definitions.
So I went to lesson 6 in the book to find the definitions of it. And the reason why I put down the law of large numbers, and this is just good review for me because I don't quite remember what it said. It said the law of large numbers states that as the sample size gets larger, the sample mean will get closer to the population mean. And the question is asking, which of the following results implies that the spread of
Good point.
of x? So x with the line over, that means the mean. What does that mean?
it's the mean of the mean, right?
The mean,
Yeah.
mean of the means.
It comes to get the middle come together and get closer.
Yeah, so the spread, or in other words, kind of like the standard deviation, it will decrease as the sample size will increase.
Makes sense.
I don't know.
I think you're right.
Okay. Well, we can find out. We've got we've got multiple tries, so
Yes, we
we'll
do.
try it. So we're going with law of large numbers then? Is that what we're doing?
Yep.
Okay.
Yeah. And then that's as far as I got.
Okay. So for question 6, and if basically we can collaborate on this, and if you agree with us, then Stephanie, you can just put down what we say, and that's just fine.
I'm going to go back through and work through them anyway.
Sure. So question 6, I put down as my answer 1.045.
Yes.
Is that what you got, Carrie?
Yeah, I
All
thought
right.
I thought it was wrong. I was like, this is just too easy.
Yeah.
Okay, so did you just use a z-score formula?
I don't
Yeah.
remember what I did.
The one that we learned back in.
That's what I
Oh,
did.
yeah.
So z equals x minus mu over standard deviation.
Mhm.
Okay.
So it's 160 minus 50.8 over 8.8, and that gets you to the 1.045.
Yeah.
Okay.
So that's
I put-
that's basically just
put-
like the questions that we've done in the last lesson.
Yeah.
Because
Okay.
it's just we're only dealing with one person. So
Okay.
I put on 1.06, but I'm using my phone as a calculator. So
oh, okay. So it says
So I don't
round to 3 decimal places. So what
right.
so it'd probably be good to put 1.045 as your answer.
Okay. What
Yeah, I rounded up too
was
much.
it? 1.045.
Uh-huh.
Okay.
Okay, moving on to question 7. I put down as the answer 0.148.
I did too.
Awesome.
And what was the formula on that one?
So it's asking for the probability that a randomly selected student would score above 160 on the GRE. So basically what I did is I found the z-score. Well, actually, no, just kidding. We found the z-score in the last question,
Right.
which that student had scored a 160. So you take that z-score, which was 1.045, and you plug it into the normal probability applet.
Oh, you did into the applet?
You just put that z-score in there, and then it's asking what's the probability that a student would score above that, and
But
so
if
you
it's
just
right.
it's just exactly you highlight the right, and
Okay.
it'll give you 0.148 as the probability.
Okay. Perfect.
Okay, so question
I'm
8.
asking so many questions.
Oh, well, that's okay. Question 8. So this is where it kind of gets into the actual part of lesson 7, I guess, because we're talking, instead of talking about one student, we're talking about 5 students now. It says a random sample of 5 students was selected to take the GRE. It gives their scores, and it's asking what's the z-score corresponding to the sample mean of all of these student scores. And I put down 2.338.
Oh. I got 0.266.
0.266.
So okay. So what's the formula? Let's go through it.
Yeah, let's do that. see if I can find it. 2.33. Okay, here it is. So this is what I did. And you can, you can tell me if I did this wrong. But anyway, it's basically the z-score, because we're looking for the z-score. So you take that formula, and what I did is I found the sample mean of all those students. So I added up all of the scores, and I divided by 5 because there's 5 students. And what I came out to was 160 was the mean of all of those students.
Right.
And then I took 160 and subtracted 150.8 because 150.8 is the average GRE score according to the information we were given.
Above.
Above, exactly.
Okay, that's right.
And then I divided 8.8, but then I also divided 8.8 by the square root of 5.
Okay.
Is that, well, let me put it up on the.
No, yeah, that makes sense. That makes
Yeah.
sense. Let me just plug
We're
it in.
using the new formula that we learned in.
Hey, Dakota,
Yeah.
what was the last part that you divided off? But the square root of, what is it?
So is the square root of 5 because there's a population size of 5 that we're looking at. This is it's kind of wonky on my paper because I used whiteout on it. But anyway, there's the equation here. So the z-score is equal to 160 minus the 150.8 divided by 88, which is also divided by the square root of 5.
Mhm.
And then that came out to that number, 2.33771, which I rounded to 338.
Yep, that's what I got when I put it in.
I redid it. I was using I mixed up my numbers on my stuff here. So
Oh,
So 2.338. I got that as well when I plugged it in.
okay. Awesome.
okay, so that's the answer. Let me change that. Which one are we on? Oh, number 8.
Yeah, question 8.
So it's 2.338.
Yep.
Okay. Okay.
At least until further notice.
Till we hit submit.
Till we hit submit. So question 9, I put down 0.0097.
Okay, so what's the okay, so what's probably
Oh, are we just putting the 2.338 into the Appulet
I
to get
think
that answer?
so. Let me
That's
look
why
at
mine
it.
didn't go.
Oh yeah. So you're right.
What's the probability that the 5 students will have a mean score that's greater than the mean achieved by the students in the previous problem? What did I do for that one? I'm trying to find it on here. Let's see. What's the probability that 5 students will have a mean score greater than the mean? Oh, yeah. So, yeah, I'm pretty sure that's right. So, yeah, it's basically just asking us to put in the z-score on the probability applet and then
And what was your
highlight.
answer?
I put in 0.0097.
Okay, that is what the applet says.
That's what I just got.
Yeah. And that would make sense in my mind because basically what that is that's a really low percentage. That's like 0.97. So it's not even 1% of the population will do higher than the students that we're observing.
Mm-hmm.
And the reason why that makes sense is they've got high GRE scores. You know, one student got a 160, another student got a 175, and the mean is a 150.8. So, I mean, these are really high scores. So it makes sense that it's going to be a very low percentage of students doing better than them.
Yeah.
So, okay. So moving on to question 10. I put down approximately normal.
I did too.
I would think so too, because of the sample size, right?
Uh-huh. Yep. Yeah, that one I was really confused about for a little bit, but then I actually went to the sampling distribution little tool that was it was on the
Oh, the bar, the histogram, and then it.
yeah, you can kind of change it and whatnot, and I played with it a little bit, and eventually I came to that. So if you guys are cool with that, then that sounds
But
good.
isn't it just, it wasn't that we didn't say just like the rule of thumb if everything's over 30? That you're
If
pretty
everything's
much
over
normalized?
30, then for the most part, it kind of just evens out to being normal.
Yeah.
Yeah. Which is really fascinating. I never really knew that because
I didn't either, and I thought whatever. And then as I watched it, I'm like, that's actually pretty cool.
yeah, sure enough, it decides to go back into a normal distribution. Okay, so question 11, I put down 3.5.
I did too.
Awesome.
Okay, so what? Sorry, what? I should have done this ahead of time.
So basically, it's just asking, you know, you kind of go, well, this is too easy. It's basically asking you what the mean is in the question. So suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. So they're just asking here what the mean is of the sample sizes of 81. Is that how you understood it, Dakota?
Yeah.
So how are you? Okay, so but how are you finding the mean?
It's in the above.
So-
Just above 10, it gives a little information there. It says that the mean is 3.5 and the standard deviation is 0.7.
So are we
It is
just
well known that the distribution is skewed left and the random is 81.
Mm-hmm. Yeah, so I think all I did was I just saw that it was 3.5 was the mean for the students, and I just put that number in.
So 3.5 is the answer.
I think so.
Well, let's hope so.
I hope so.
I'm just making sure.
It is
that-
for right now.
Yeah.
So
Okay, but I'm blanking here. I'm sorry.
Yeah.
I have like Friday brain on a Thursday. I'm not getting where you got, and maybe it's just too easy. I'm overthinking it.
What is the
Where the
normal
3.5
Right, that's what I mean. If you look right above 10, it gives you our story problem. And in the story problem, it's talking about the mean, and the mean is 3.
Oh, okay, gotcha. Okay,
So it's in like in my mind, it almost sounded like they were asking in a like a roundabout way.
Yeah.
Like, what's the mean of the population? And it was 3.5.
And where did you get the 3.5 again? Sorry, I was.
So there's an information thing that's just before question 10. It talks about the GPA of BYUI students.
Uh huh.
and
So it
gives you the
says,
answer in there.
it says the mean is 3.5.
Mm-hmm.
And then there's a
Okay.
standard deviation of 0.7.
Okay.
Yep. So
Well, it just
now,
threw me off, but when it throws in this 81, you're like,
yeah, it's kind of weird.
Yeah, it looked like you were supposed to calculate something.
yeah.
But-
Trick
Yeah.
question. Okay.
Mhm. Now for the next one, it's asking what the standard deviation of the distribution of the sample means for all possible samples of size 81. Now, I didn't actually put down 0.7 from the information. I put down 0.078. Is that what you got, Carrie?
No, I just put 0.7.
Okay, 'cause it's very possible it could just be 0.7.
How did you derive at yours?
So what I did, I saw in the book somewhere. So I'm going to go to lesson 7 here. I'm pretty sure there's something that talks about standard deviation. Let me see what I did here. Where's my work at? We're on question 12, right?
Yeah.
Yes.
7, 8.
And also because like it says like 3 decimal places, and the other one is just point 0.07 or 0.7.
Oh, here we go. So standard distribution of the distribution of sample means is equal to sigma times the standard deviation divided by the square root of n.
Oh, so we're using that formula on this? Okay.
Supposedly, I don't.
Well, can you read it again? I'm just trying to look for that formula.
Yeah. So sigma. Well, maybe it's. Is sigma the standard deviation? Is that what that is? Is that what sigma is?
Yes.
Yeah.
So-
Yeah. So it would be sigma over the square root of n.
Okay, so
And
finding
then-
the area under the
Dakota?
curve sample.
Dakota, what did you get?
For the answer, I got 0.0778. Well, basically
Oh, Okay.
0.07777, whatever. But
Wait,
in
wait,
the
wait,
answer, I rounded it to 0.078.
So wait. So Dakota, you did 0.7, right?
Uh-huh.
0.7 divided by.
The square root of the
Oh,
sample.
that's what I was missing.
So
Okay,
the
that's
sample
true.
size was 81, I believe. Is that right?
Yeah. You.
Yeah. So the square root of 81 is 9. So it's 0.7 divided by 9. And that's where I came up with 0.078 when I rounded.
Okay. Hang on. Do you mind if I just plug it in real quick?
Sure.
Go ahead. So it's 0.778. Okay.
It says round to 3 decimal places, so I put 0.078.
Okay, I got it. Perfect.
Nice. So I don't know if we're supposed to use that
Oh, sorry.
that equation, but it seemed right to me.
We'll find out.
We'll find out.
So 0.0. Oh, we're not putting in the other 0. So it's just 0.07 or 78. Okay.
Yeah, as long as you just have 3 decimal places. Yeah. Okay, question 13. I put 0.005.
Oh, this is an applet question, right?
Yeah.
Oh, I must have done that wrong.
Okay, so what did you plug into the applet?
That's a good question. I don't remember.
I hate the applet. I'm just telling you.
Let's see.
I
Probability less than 3.3. And what was 3.3? Oh, 3.3 was, that was like -2. Well, no. Yes.
I got negative 0.2574.
Yeah.
I'm just trying to figure out how you derive out what to plug into it.
Oh, this is what I did. So we're on question 13, right?
Correct.
Okay. So what I did was we're looking for the probability of students that will be less than 3.3. And wait, the thing though is there's a sample size of 81. We're not just talking about one student. We're talking about 81 students. Right. And so you take that z-score equation with the number in it that's been added into it. So it'd be 3.3, which is that observed number, minus the mean, which is 3.5, divide by 0.7, which is the standard deviation, divided by the square root of 81.
81. Mm-hmm.
And that'll give you a z-score of -2.5707.
I'm sorry, negative, what was it?
2.5707.
Okay, and then I put that into the applet.
And it's asking
for less than, right?
Less than 3.3. So go less than, shade in the less than for -2.5707.
And what was your answer that you got?
I got 0.005 when I rounded to 3 decimal places.
Okay. All right, I got that.
Okay.
Now, how did you get that out of the applet? Because I put in 0.257, and I clicked the left, but when I put in the z-score, it highlighted the left and the middle.
Just unclick it.
Yeah, just unclick it.
Because you don't want everything in the middle. You want everything less than 0.25.
Okay.
So what the line on the left is the negative, so it's everything beyond that.
So what was the probability?
I got 0.005 as my answer.
I did too, when I plugged it in.
Coming out. Why?
Carrie, sometimes I have problems with my applet. Like clear your area and re-putting your z-score and with your left clicked initially. Sometimes that does it for me.
Okay.
Yeah, that's what I was trying to do because mine wasn't really working either.
Okay, so we're putting in, I want to make sure I'm putting this in right, negative 0.257.
Yep.
0.257.
No, 2.571 for your z-score.
Well, I put in negative.
Yeah, well, negative, yeah.
0.5.
Oh, okay. Yeah,
It
got it.
automatically makes the right positive.
Oh, right. Yeah.
So it's 2.57?
You can put in either because, yeah. What I did here, let me show you on my
No, now it's
screen.
0. Okay, that'd be great.
Let me show you on my screen here. So I'm going to share real quick. Share screen. Here we go. Let's see. Let's do desktop. And I'm going to go here. Okay, so here's the normal probability applet, right?
Yeah.
And so what I did is I'm right here is where I'm plugging it in. You could technically go over here and plug in the z-score, but just because I know that we're looking at 3.3, which is below the average, I like to just keep things simple, and I just know that, okay, if we're looking at something below the average, I just go down here and I plug in negative 2.5707, and we're only worried about this part right here. So I unclicked. This actually was filled in at first. It's kind of hard to see, but that is blue. So I unclicked it because we're not concerned about that. We're only concerned about this little spot right here to the left of that. And that gives you the area, the probability 0.0051.
Oh, okay. I didn't carry out the numbers far enough.
Gotcha. So does that help?
That does. So that's number 13. Okay. Thank you.
Yeah, you bet. So let me get back to my little sheet here. Okay, so that was 13. Question 14, I put 0.995 because basically the question is just asking what's the probability that there will be students that will have a GPA greater than 3.3.
So it's the middle and everything right?
Exactly. It's everything to the right of what we just put down. So think of that z-score. The z-score hasn't changed at all on that probability applet, but all we've done is we've unshaded the left portion and we have shaded everything to the right now.
So the middle and the right?
Exactly.
So 0.9949 or 0.995.
Yep. Yeah, because it's asking for 3 decimal places, so I put down 0.995.
Nine 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 five. Okay.
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 0.995.
Alan, how's everything looking? Are you
Well, I am getting those.
okay?
I just don't want to talk over you guys because every time I try to say my answer, you're saying something or A1 is also saying something.
Gotcha. Just wanted to make sure we're all on the same page.
Yeah, no,
Okay.
I'm good.
Cool. So question 15, then I put down 0.038. This one took a little bit of, and I don't know if I did it right, but what did you get, Carrie?
I got 0.0274.
Okay. So this is what I did. Well, first off, let's just read through this thing. So it's asking, find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than was observed in this sample. So lots of information in this question, but if we break it down into little pieces here, one thing that we'll find out is the U.S. Coast Guard assumes that the mean weight, the average weight of passengers just all across the board is 185 pounds. So no matter where you are in the world, if you're on a boat, the average person is going to be about 185.
So that's mu. Mu's 185.
Yeah, so that's mean weight is what I labeled it. I don't know if that's really the best label, but I put down mean weight as just a label for it. And it says that the standard deviation of that weight is 26.7 pounds. So I went ahead and I wrote that down. And it also says that weights of a random sample of 48 passengers were recorded So we have a number, we have a sample size of 48. So I went ahead and wrote that down. But now it says that the sample of those 48 passengers was determined to be 177.6 pounds. And so that is the extreme that they're talking about. So instead of being 185 pounds, these passengers collectively were 177.6. So the way that I went about this is I found the Z-score extreme for the low side, and I also found the Z-score extreme for the positive side. And basically the way that I did that was the difference between 185 and 177.6 is 7.4 pounds. Okay. So basically what I did is I took 7.4 pounds. Sorry, just kidding. I did 177.6 minus 185. I plugged it into the Z-score. You know, you have the observed weight minus the average weight. So 177.6 minus 185
How are you, buddy?
divided by 26.7 divided by square root of 48.
What are you doing?
And that gave me a Z-score of negative 2.076.
What was it? -2?
Negative 2.076.
I'm sorry. Say it one more time.
That's okay.
-2.
So negative 2.076.
Okay. Thank you.
And then for the positive extreme, so let's say we have that same difference in weight, which is 7.4 pounds, but we add it to 185 pounds. Okay, so now we have, this is probably not necessary, but I did it anyway just to put all my numbers together. I did 185 plus 7.4 because that's the positive extreme. The other side is what they're asking for, which would be 192.4 pounds, which is now our observed extreme, minus 185, divided that by the standard deviation, 26.7, divided that by the square root of 48, which is our sample size. And all that together was a Z-score, which was positive 2.076, which is it's the exact same Z-score, but
Just
a
the
positive.
opposite ends. Yeah.
Yep. So now that we have both of those Z-scores, the thing that it's asking is find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than both sides. So there's a note in there that says as extreme or more extreme means that we're not only interested in the values that are lower than the ones that we just observed, but also the values that are as far away from the mean as ours on the positive side. So what I did was I took the normal probability applet.
Mm-hmm.
Let's see if I can find it.
You
I'm going to share my,
two sides.
yeah,
Where did you find that? Was that in the chapter where it told you the extreme?
What's that?
Where you're saying the extreme, it says, you said that you read where if it's extreme, this is what you do. Was that in the chapter reading?
I just kind of put it all together in my head because the extreme in this question was 177.6 pounds. So instead of it being 185 pounds, which is the average for, the normal passenger, it was 177.6. So I'm going to share my normal probability applet with you guys so you can kind of follow along with that as soon as I can find it. Where is that thing?
You have it up.
I've got it up. Well, I shared the that app itself. Oh, here it is. Okay. So here's my normal probability applet. I plugged in negative 2.076 on this, and it also gives you 2.076 on the other side here. And I just highlighted both sides, and I got the area here.
Okay. So it's the two extremes, really high and really low.
Exactly. Yeah. So that's how I interpreted it. I don't know if you guys feel the same way.
How did you do yours, Carrie?
Well, I kind of did it the same way, but I came out with a z-score of negative 1.920, and I put that into the applet.
Do you
And
think
came
you
out
could?
with your answer of negative 0.02746.
Okay.
So I don't know.
Do you, did you want to run through it on how you did it?
Well, I just I did the same as you. I took 177.6 minus 185 over divided by 26.7.
Yeah, I'm getting something different too.
Divided by the 48. So when I subtracted 177.6, 185, I got negative 714 over 3.854. Then I divided that out and I got negative 1.920.
Was your number so 48? Was that the square root of 48, or was that just 48?
That was the sample, the square root of 48.
Okay,
Unless
let
I
me.
did that wrong.
So
26.6.
is it the z-score without the square root that we're doing, or the one with the square root?
It's the one with the square root.
So it's 176.6 minus 185 divided by 26.7 divided by what's the
Square root of 48.
48. I missed that part. Let me plug it in.
Oh, you know what?
Negative 0.31715.
I might have something different here. I might have the wrong number.
Carrie, what was the answer you got?
The z-score was negative 1.920.
Okay, what am I doing?
Yep. You know what? I think I had a miscalculation. I put in the wrong number. So I plugged it back in and I got negative 1.9201. Yeah.
Okay.
So now, if we plug that into, let me share my screen again. So let's see where am I here? I keep losing my applet. Oh, there it is. Okay.
What was the answer you got, the z-score?
So the z-score was negative 1.9201.
I got negative 1.971. Maybe I hit something wrong. So 177.6 minus 185 is negative 7.4.
7.4.
Okay, and then 26.7 divided by the square root of 48
Yes.
is 3.85.
3.8, and I rounded it to 3.854.
By 4. Okay, let me try it that way. Maybe that's why I did it wrong. Negative 1.920. Okay.
Yep.
Okay.
Yeah, so now I plugged that into the probability applet and I got 0.0549 as the probability. So I rounded that to 3 decimal places, so that's 0.055.
Yeah, perfect.
Is that what you got?
Yep.
Yeah.
Yeah, I'm not sure where I went wrong there. Well, I know where I went wrong, but I'm not sure how I went wrong.
Did you want me to try it then?
Sure. Yeah, if
I
you're
can try it.
up for the challenge.
All right, I'm doing it. Let's see. Okay, so 3 we got wrong. I don't know if you guys had the same answer as me.
What
And then
was
we
your
got,
answer for 3?
for 3, I got 0.0175.
Oh, I got 0.175.
Oh, 0.175, so no 0?
No, 0, yeah.
Okay.
I need.
And then number 9, it's wrong as well.
So what did you get for
And I
9?
got 0.0997.
No.
So I got 0.0097.
Yes.
Oh, so those 2 zeros, 97.
Yeah.
So it was my fault then.
That's
And
okay.
then number 15 is wrong too. I'm just kidding. No, that one's right.
I'm like,
I
what?
was-
It's like, well, it's going to stay wrong.
All right.
Nah,
I'm
I know it was just like a lot of work. Yeah, that was it. That was it. So you guys are probably gonna get 100.
Okay, let me
got
go
100.
ahead and, oh, you got 100? Sweet.
I got 100.
So we take all the zeros off of the front of all these because I had zeros.
Well, I guess it doesn't matter either way. It's the same number. but-
Yeah, it's the same number. I think the thing is there was just decimal issues with Alan's answers.
Oh, okay.
Yeah, he had the decimal in the wrong spots or something like that.
Could you give them to me real quick? The answers.
Yeah,
That way I don't have to go back and look at them.
yeah, you bet. Are you ready?
Okay, let me just finish 2 and 1.
Hey, I have to
I
tell
want
you
to
guys,
false.
thanks for saving my bacon today. And I have to tell you, I've been doing online at BYU 3 years. I've always complained about groups. I like this group.
We've got a good group. We got a good thing going here. I'm glad it worked out as good as it did. My wife, I told you my wife took this class, and she said that her group was horrible. She hated her group. It was just she ended up doing the work, and then everybody came to the group meeting, and
They knew she would do it.
and they knew that she would do it exactly. So she hated it, but I think we got a good thing going here.
I think so, too.
Okay,
awesome.
so for number
Well, the way the group is supposed to work, where you help each other out, come and help each other out. So.
Yeah.
Right.
So number 3 is 0.175.
okay,
Question 4 is the distribution of the sample means X.
okay,
Question 5 is the law of large numbers.
okay. 6,
6 is 1.045.
1.045.
Mhm.
7,
7 is 0.148.
0.148. Got it.
Okay. Question 8 is 2.338.
Got it. 2.338.
Yep. Question 9 is 0.0097.
Okay.
Okay. Question 10 is approximately normal.
Question 11.
Question 11 is 3.5.
Okay.
Question 12 is 0.078.
078.
Yep. 0.078. Is that what you got?
Yeah.
Okay. Question 13 is 0.005.
Okay.
Question 14 is 0.995.
0.995.
Yep.
Okay.
And question 15 is 0.055.
Question 10, question 9. Okay. Got it. Let's see if I get 100. Hopefully. So, you know what I was thinking? Like, even if we don't get prepared, like, it's going to hurt us at the end because on the test, it's going to be all on us, you know? Like, we won't have the group to help us.
Right.
So
What?
if you don't really put the effort right now, like at the end, you are the one who's gonna be in trouble. You know?
Well, I think if we're all prepared when we come to class, regardless, it just makes it go by faster, and then we're not in. Like today, we've been almost an hour.
Yeah.
If we're all ready and we have our tests in it seems to go smoother. So we have to encourage each other to have it done, not slacked.
Well, that's
The test
okay.
is
That's, you
individual,
guys
right?
saved me last time, so that's,
All right.
that's just how it works sometimes. Oh, just a heads up. So next week on Tuesday, I will be coming back from an interview at Utah, University of Utah,
Okay.
and yeah, supposedly it's gonna be a pretty long one. So I'm gonna try and get everything done, but if I'm falling behind, then that's
That's okay.
that's the last interview I have so
Oh,
far.
you're okay. Do you need us to push the time back?
No, I think we should be okay because
Okay.
I've got a meeting afterwards. So
Okay.
I'll just we'll leave it at 6.
Okay. Sounds
Well,
good.
if you need to, just text us, and I'm good at doing a little bit later if we need to.
And so
Okay.
am I. So
Sounds
am I.
good.
And for me,
Yeah,
the later
well-
the better.
We'll plan for 6 o'clock. Just and then if anything changes, I'll let you guys know.
Okay.
Okay.
Sounds
Okay.
good. Good luck
Perfect.
with your homework quizzes.
Yeah.
You too.
Thank you, everybody.
Oh, thank you.
Thanks, guys.
Okay.
See
See
ya,
ya.
guys.
See ya.
Bye.